Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 26 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2483. Minimum penalty for a shop. Right? So let's read the problem statement. You are given the customer visit log of a shop represented by a zero indexed string customers consisting only of characters n and y. If the ith character is y, it means that customers come at the ith hour, whereas n indicates that no customers come at the ith hour, right? So customer string is given to us, right? This is 0 index, 1 index, second index and third index, right? So you can say 0th hour, first hour, second hour, third hour. So at 0th hour customer comes, right? Y. At first hour customer comes, y. At second hour customer didn't come, right? So here n. At third hour customer comes, so that is why y. Clear? Now, if the shop closes at the jth hour, j is from 0 to n, right? 0 to less than equal to n, right? So means 0, 1, 2, 3, 4. So until here we need to check j, right? J here, then here, then here, then here, then here, right? Because less than equal to n given to us, right? The penalty is calculated as follows. So for every hour when the shop is open, right, and no customers come, the penalty increases by 1, right? So shop is opened and no customer comes, right? Then penalty is going to be increased by 1, right? And for every hour when the shop is closed and the customer come, why, right? The penalty increases by 1, right? So when penalty is going to increase by 1, when shop is opened but customer didn't come. When shop is closed but customer comes, then penalty is increases by 1, right? So we have to return the earliest hour at which the shop must be closed to incur a minimum penalty, right? So we need minimum penalty, right? So earliest hour we can close the shop, right? Note that if a shop closes at the jth hour, right, it means the shop is closed at the rj, right? So if at first hour I'm closing my shop, so I have to treat the shop as closed, right? I have to treat the shop as closed, right? So if shop is closed here and here it is y, right? Customer comes and shop is closed, then penalty is there, right? So let's discuss this, right, with an example here. Very easy problem actually, not very difficult. Okay, so here this is your example number 1, right? So closing the shop at 0th hour, right? At 0th hour if you close the shop, right? So here let's calculate the penalty, right? So you are closing the shop at 0th hour. Here customer comes, right? Penalty is going to increase by 1. Here customer comes, penalty is going to increase by 1. Here customer didn't come, good, no problem. But here customer comes, so penalty is going to increase by 1. So total 1 plus 1 plus 0 plus 1 is nothing but 3. 3 is going to the penalty in this case, right? Clear? This is done. Why 3 is coming, right? Okay. Now after that, let's suppose you close the shop at this particular jth hour, right? So you close the shop here, right? But here, as of now you close the shop at jth hour here, but as of now shop is opened at 0th hour, right? So here there is no penalty. But here you close the shop and customer comes, right? So there will be penalty. Here your shop is already closed and customer didn't come, good, no penalty. Here your shop is already closed, right? But customer comes, so there is penalty, right? So closing the shop at 0th hour, at first hour, incurs in 0101, that is 2 penalty, right? So just add everything, you will get 2. That's it. Clear this part? Now next time, let's say you close your shop at this particular jth hour, right? Let's say you close your shop at this particular jth hour. Okay, so here shop is opened and customer comes, good, no problem. Here shop is opened as of now and customer comes, no problem. Here you close the shop, right? Shop is closed, but customer also didn't come, no penalty. Here your shop is closed now, right? But customer comes, so there will be penalty, right? So that is by one penalty here. Done. This is done. Okay. Now next time what is going to happen? Let's say your J is here. Okay. So at this particular R you are closing the shop. J means closing the shop at this R. Okay. So now you are closing the shop at third R. But here shop is open and customer comes, no penalty. Shop is open, customer comes, no penalty. Shop is open but customer didn't come, there is a penalty. Now shop is closed at third hour and customer comes, right? There is penalty, right? So here if you see 0011, so penalty is 2. Clear? Done this part, right? Now easy, right? It's easy now, right? But now your J is moving until here. Now you are closing the shop at fourth hour. So if you are closing the shop at fourth hour, so here shop is opened, so no penalty. Shop is open, customer comes, no penalty. Shop is opened, customer didn't come, penalty is there. Shop is opened, customer comes, no penalty, right? Here you are closing the shop, so here's 0010, so here one penalty. Now among these five values, tell me, we check all the J's from 0 to 4, right? 0th, first, second, third, fourth hour, right? Minimum is here at second hour and here, right, at fourth hour. Among second and fourth, we need to return the earliest hour, right? So second is the earliest hour. Closing the shop at second and fourth hour gives a minimum penalty since 2 is the earlier. The optimal closing time is 2. That's it. Easy? Easy? Okay. See here, example number 2. So it is best to close the shop at 0th hour as no customer arrive. Then minimum penalty, right? 0. So this is at 0th hour, right? I am closing the shop at 0th hour. Here in this case, customers are coming, right? So I want to close the shop at my fourth hour, right? It is best to close the shop at fourth hour as customers arrive at each hour. So 4 is the best hour to close the shop, right? No penalty in this case. In this case there is no penalty, right? In this case also there is no penalty if I close the shop at 0th hour, right? Clear? Okay. Now these are the constants. Customers total length is from 1 to 10 power 5, right? And customers consist only of characters y and n, right? So here tell me, I'm closing the shop at jth hour, then here I'm iterating my j from 0 to n times, right? And then after that, do I want to again and again calculate the number of y's and n again and again for all these 0 to n, right? Definitely, if I'm closing the shop at this particular position, I need to take care of the number of ends here, right? Because if I'm closing the shop at 3, right? Closing the shop at third hour. So here only I'm going to get the penalty when n is there, right? When customer didn't come and my shop is opened, right? Definitely at this particular jth hour also I need to check, right? At third hour, if I'm closing the shop here and here also customer comes, then this also I need to check, right? And here also if I have some more values, let's say n and y here, so in this case also if I close the shop and here customers come, so here I have to take care of y's, right? In this case, so do you want to me to run j loop from 0 to n here and again here calculate first in the left side n values, then check this particular case at jth hour, then here in this side you want me to check y? So definitely I will get time limit exceed error, right? So definitely I'm not going to use the brute force, right? Because definitely I'm going for n square, right? So here 10 is to the 5 square, 10 is to the 10, definitely I will get time limit exceed error, right? So I need some optimal approach, right? So I want my optimal approach to give me the total number of y's in this side or in this side pre-calculated. So pre-calculated means I can do prefix count, right? I can find the prefix sum, right, of the y's or of the n's, right? Whatever I want, right? So to avoid the calculation again and again of y and n, I can create one prefix array, right, to store the counts of y, let's say. Okay, so how I'm going to do that, let's see here. Example number 1, same example, right? So here n is nothing but 4 customer store length, right? So create a array, right? Let's say array name is count of y, right? And in this count of y, let's give the same length, right? So 0 index, 1 index, 2 index, 3 index, right? Okay, now here tell me, it is given that customer store length is always starting from 1, right? It minimum is 1, right? It will not be 0, right? So definitely at least one length of string will be there for these customers always, right? Right. So in that case, what I will do here, I will check I will check here if I have y, then here in the prefix count I will write I have seen one y here as of now until here, right? If in this particular position I have n, so I will take 0 here, right? But as of now here I have y, so here I am keeping the count as 1. Next time I am moving here. Okay, so previous time it's 1, right? And I am seeing one more 1, so it is going to become 2. Done. Now I move here, right? 0 index, 1 index, 2 index, 3 index. Now I move to 2 index. So previously I have seen 2 y's and this time I have just n, so there will be no increment. So this 2 is showing that until this index how many y's are there, right? I am just keeping track of y's. Now here until here we have 2 and I have seen one more y at 3, so here I am writing 3. So this is how I am going to fill my count of y. So now using this, it will be very easy for me to calculate y's and n, right? How it is very easy. So definitely at this particular position, I will have total number of y's in my string at this particular position, right? I'm just calculating the total number of y's, right? At this particular position until 3. Until 3 is nothing but the last index. So until here I've calculated total y's, right? Now minimum penalty, right? So when I'm going to get the minimum penalty, right? This I have to find out the minimum penalty, right? Minimum penalty. And when I'm getting this minimum penalty, for that minimum penalty I have to find out the best r, right? Earliest r I need to close the shop, right? Earliest r I need to close the shop, right? So let's say you are iterating your j from 0 to 4, right? You are iterating your j from 0 to 4, right? That is nothing but a time when you are going to close your shop, right? So let's say you close the shop at 0 itself initially, first case, very first case, right? Basic case, definitely there will be at least one value in the string. Okay, let's say at 0th hour you close the shop. So in 0th hour, let's say you close the shop, so let's say best r is 0. Okay, now in this case the penalty will be, how much penalty you will get, you will have to pay, right? Minimum penalty we have to find, but in this case how much penalty you have to pay. Okay, so you are closing the shop here at 0th hour, 1 2 3 4, at 0th hour you are closing the shop, and here total number of y's is, okay, let's understand it like very basic first, right? So you are closing the shop at 0th hour, so here you are closing the shop and customer comes, y, right? Penalty is there. Here also penalty is there, shop is already closed. Here there is no penalty, but here y, customer comes but shop is closed, so penalty is there. So total penalty is 3, right? Total penalty is 3, right? Here in this case total penalty is 3. Okay, but here itself you are closing the shop, right? Initially itself you are closing the shop at 0th hour, right? So definitely you will always get the penalty when total y number of times, total number of y's in your string. So I can say your min penalty is nothing but total number of y, right? Total number of y, right? You are closing the shop here, closing the shop, right? So at from starting from here, this shop also you have to treat it closed, right? Starting from here you will always get the penalty when the customer comes, if and there is no penalty, right? But here you are closing the shop itself and then customers are coming, that simply means y, right? So total number of y is nothing but your minimum penalty as of now, right? Clear this part? This is nothing but I am saying closing at r0. Okay, done. Now I have to check closing at r 1 to n minus 1. N minus 1. I'm saying n minus 1, but definitely I need to check for nth also, because j is running from 0 to 4. So 0 I'm checking here, here I'm checking 1 to n minus 1, and here in the end I will check closing at r n also, right? So now let's see what we need to do here. Very easy, this problem is not difficult. Okay, not difficult. Okay, now this prefix sum that we are calculating, this is very important. Okay, now let's say you are closing the shop at first hour, closing the shop at first hour. Okay, so in this case you have hours like this, uh, 0th hour, then first hour, then second hour, then third hour, then fourth hour. You are closing the shop here, right? So until here shop is opened, and here in all these hours shop is closed, right? In all these hours your shop is closed, right? You can say closed, and here closing, but here also it is closed. Here definitely closed, right? At this you are closing to closed, and here closed. Okay, now see, very important, very important. So here when your shop is opened and customers are not coming, right, then you are going to get the penalty, right? When your shop is opened and customers are not coming, right? So that simply means, let's say shop is opened but customers are not coming, so open penalty, let's say, right? Okay, and here your shop is closed, right, but customers are coming, so let's say this is nothing but closed penalty. Okay, and this, you can say, this particular r when you are closing the shop, right? So in this r, one particular r but is going to be penalty, right? So in this r you are going to get the penalty when you are closing the shop but customer is coming, right? Customer is coming, right? So these three cases only I need to write, these three things. Very simple, it's not difficult. Okay, so in this case, right, your, this is first hour, this is 0th hour, right? So in 0th hour, you, what you have to calculate, you have to calculate what? So you are at the, your, let's say this is your I is at this first hour. Okay, so in this case I can say I minus the count of y at I minus 1. So I am saying until here tell me the count of number of y's, right? Because here if I know the number of y's, right, and I subtract it from the my I value, that is nothing but 1, and count of y at 0th, until 0th only 1 y is there. So 1 minus 1 is nothing but 0. That simply means until here I haven't seen any n. Clear this thing? Okay, so here let's say y n y, and here let's say y. So here you are closing the shop, closing the shop. So 0 1 2 3 4. So at fourth hour you are closing the shop. So in this side you need the total number of ends. So total number of ends is nothing but, it's nothing but your this I index I, right, here where you are closing, minus the count of y until here, it is nothing but 1 2 3, right? So I is nothing but 4. 4 minus 3 is 1. So see, you are getting 1 only, 1n, right? So this is the formula that I am using. I minus count of y at I minus 1. Clear? This thing, right? Now in the close penalty, I just need to calculate the number of y's, right? So I can calculate it like this. I know this is nothing but, let's say, my total number of y's, right? Total y's. So in total y, I have to subtract the number of y's that I have until here, right? So this is total number of y's and this is the number of y's until here, so definitely I will get the number of y's here, right? So here I'm writing count of y at I. So this is for this. Clear? Easy. Now at this particular position, right, R penalty. So here you have to check if customer is coming, right? If customer is coming, so you can say customers dot char at I index if it is equal to y, right? In that case you have to count this penalty, right? If customer is coming and you are closing the shop, otherwise you have to calculate 0, right? So this is what you need to do, right? This is for R penalty. So only these formulas, these three things I have to check, right? Clear? Right? Okay, this is done, right? Okay, and here I am writing I because it is 0 based, right? So definitely until here there is one value, right? Here if you see why I'm writing just I here, okay, don't get confused. 0 1 2 3 4 5. So your I is, I'm taking this I here, okay? So I is 5. This 5 is nothing but, if you see it diagrammatically, this I is 5 means total number of R's. So this R I also I need to calculate on 0 1 2 3 4. So overall these are 5 only. So I can simply write I minus, and here until here how many number of Y's I have seen. So here I have seen Y's, let's say 3. So 3 my total 5, 5 minus 3, I will get 2 as number of ends, right? Very basic thing. Okay, so this is what you need to do, right? So you now know how you calculating this. You are calculating this, right? Okay, this you done. This we will check. Okay, this we will check later, right? But here during this finding, right, open penalty, R penalty, close penalty, right? So if the total penalty is nothing but open penalty, R penalty, close penalty, right? So you are going to add all this stuff, that is going to be your total penalty, right? So if total penalty values come to be less than this mean penalty that I'm taking, right? So in that case, if total penalty comes out to be less than mean penalty, then in that case you have to update your mean penalty to the new penalty, right? And best hour to the current hour. Okay, at this particular hour when I'm closing the shop, I'm going to get the mean penalty, right? So this is basic thing, right? Okay, this is what you need to do, right? And how are you are going to calculate the closing at our end, right? So this is very easy, right? So you are closing the shop in the end here, so that simply means you are going to get the penalty when n is here, right? So you can say total number of what is the total value, total n value is nothing but 4, and tell me total number of y's 3. So 4 minus 3 is nothing but 1. So total number of n's you need, right? So closing at Rn, so that simply means all day open penalty, you can say n minus total y. Okay, so if this penalty in the last, okay, if this comes out to be more less than the mean penalty, that we are calculating here, right? In that case you have to return the best R as n value, that is nothing but 4th. Okay, so that's it. Very simple. Okay, very simple problem, nothing complex, right? Right, so now let's write the code. Same story, whatever I explained. Okay, same formulas I'm going to use. So here int n is nothing but, this is a string, so you have to write customers dot length, right? And then after that you have to create count of y as new int and n here, right? Now after that you have to calculate the prefix count of y. Okay, so here what we are going to do, first count of y at this 0, right? So this is nothing but the customers dot char at 0, right? So if at this particular position we have y, we have y, in that case it is going to be 1, otherwise it is going to be 0, right? Clear this thing, right? Now you have to run one simple loop for int I is equal to 1, I is less than n, and here I plus plus, right? And here you have to update your count of y at I, right? Is going to be nothing but, you can simply copy this count of y at count y at I minus 1, previous I am picking. And if in the current position, right, if in the current position we have, if in the current position customers dot care at current position, right, if we have y, then I have to add 1, otherwise I have to add 0, right? That's it, this is done. Okay, and after that, here you have to calculate the total y's. Total y is nothing but it's going to be the count of y at last index, so you can say n minus 1. Done, this is done. Now let's say you are closing the shop at r0. Okay, so in this case, int min penalty is going to be total of y, right? So just copy this, paste it here, total y, and int best r is going to be 0, right? Because you are closing the shop at 0, right? Now after this, let's say you want to find out closing at r, uh, you can say here I, right? So that's the premise. I'm running one I loop from 1 to n minus 1 until here, right? 3 cases I told you, right? uh, inside this. Okay, so here I'm running from 1 to n, n minus 1, right? So here I can simply write this, right? Okay, now inside this, uh, again I will write n in open hours. So in this case I have to calculate the penalty, right? So that simply means I'm going to say 0 to I minus 1. It's not in the current hour, previous hours, and the previous hour when my shop is opened, right? So I have to find out when customer didn't come, right? So in this case, int open penalty, right? So I'm going to write these 3 cases: open penalty, r penalty, close penalty, right? Same from I minus count of this one. Okay, so here I minus count of, I can simply copy this, right? I minus count of y, I count y I minus 1, right? This is done. Now after this I have to find out y in closed hours, not opened, closed hours, right? Y in closed hours, and from where? From I plus 1. I'm not checking at current hour, from the next hours, I plus 1 to you can say n minus 1, right? N minus 1, right? So in this case, int closed penalty, right, is going to be what? Closed penalty is nothing but total y minus count of y I, right? So here you have to write uh, total of y minus count of y at I, right? So this is how you are going to calculate this, right? Now here you are going to calculate contribution of r I, current r itself, right? Itself. So as we are closing the shop here, right? Closing, okay, closed, right? Contribution of r I itself, right? So here I'm going to say this is opened, this is closed penalty, and now I'm going to say int r penalty, let's say. Okay, so this is going to be nothing but, I will check if the current character is y, right? That simply means customer is coming and I'm closing the shop, then I have to calculate 1, otherwise I have to take 0, right? So here I will write what? I write this thing, copy this, paste it here. So customers dot char at I, if it is equal to y, right, then take 1 in this case, otherwise take 0, right? Okay, this is done. Now total penalty, right? Total penalty I have to calculate. So int penalty is going to be the, I have to just do the addition of all this. Open penalty plus, copy this, paste it here, close penalty plus, copy this R penalty and add it here. So this is going to be your total penalty, right? So now here, if this penalty, right, if this penalty, I will say if it is less than the min penalty, right, then in that case your min penalty is going to be updated with the current penalty, right, because I have to take a minimum penalty only, right? And the best R is going to be the current R, right, at which this all things are happening, right? So this is done. So that's it. So this is for closing at R from 1 to n minus 1. Oh, okay. And now this is closing at R0, this is closing at Ri 1 to n minus 1. Now closing at Rn, right? So three things we have to check, right? 0 to 4. So this, then this, and then this, right? Until end. Okay, and last. So here closing at R, this closing at Rn, right? Closing at R0. Three things we are checking, right? So now here I will say closing, I will copy this, okay, and I go here, and here I will write closing at Rn, right? So now see what I will do. So let's say int, and here all day open penalty n minus the total y, done. And here we have to return what in the end we have to return. So this all day open penalty, right, if this value comes out to be less than the min penalty, right, in that case I will just simply return n, otherwise I will return the best R. That's it. Okay, so see, only 32 lines of code, right? Now let's run it and see if the code issue will try to fix that. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And the time complexity is going to be O of n, right? We are just iterating here n times. That's it. Here we are also iterating n times. That's it, right? So time complexity is going to be O of n, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.